Okay. Now, let us say another colloidal system, that is emulsion. Emulsions are a type of colloidal system in which dispersed phase and dispersion medium are liquids. That is, liquid dispersed in liquid. Liquid in liquid colloidal systems are known as emulsions. See, in emulsions, one liquid acts as dispersed phase and another liquid acts as dispersion medium. The liquid which present in small amount in the system acts as dispersed phase, and one which present on a large scale, large amount, acts as medium. Liquid which present in small amount acts as dispersed phase, and one which present on the large scale acts as dispersion medium. Best example for emulsion is milk. Milk is a colloidal system, belongs to liquid in liquid colloidal system, that is emulsion. In milk, fine particles of liquid fat, that is liquid fat particles, are dispersed in water. And in emulsion, actually there are two components, dispersed phase and dispersion medium. Apart from these two, there will be another substance or component known as emulsifying agent or stabilizing agent. In milk, the stabilizing agent present is none other than a protein known as casein. In milk, casein is present as stabilizing agent. It is a protein. Dispersed phase is fine particles of fat. Medium, water. Okay. See, this stabilizing agent or emulsifying agent, emulsifier, it is generally known as emulsifier. Emulsifier forms a thin film between dispersed phase and dispersion medium in the system, and that binds or brings the two phases, dispersed phase and dispersion medium, close together. Okay, and that is responsible for stability of emulsions. In fact, there are two types of emulsions. Emulsions are classified into two types. One, oil in water emulsion. Oil in water emulsion, often represented as O bar W. O stands for oil, W stands for water. See here, this is dispersed phase, this is dispersion medium. It present in a small amount in the system, it present a large scale or amount. Another type is water in oil emulsion, denoted by W bar O. There are two types of emulsions: oil in water emulsion, water in oil emulsion. Okay, we'll give example for this. Oil in water emulsion, cold cream. Here, water in oil emulsion, vanishing cream. Very often you use these two types of creams. Okay. cold cream, vanishing cream. In this case, of course, oil in water emulsion, another example, milk, butter, etc. Same, vanishing, in case of oil in water emulsion, the stabilizing agent, that is emulsifier or emulsifying agent, generally are in a oil and water emulsion, proteins, then soap, detergents, etc. But in case of water in oil emulsion, we use long chain alcohols. Long chain alcohols, lamp black, say proteins, soaps, detergents, alcohols, of course, long chain alcohols, lamp black, they are all used as emulsifiers in the preparation of different types of emulsions. So this is about emulsions. Next bit is, see, if you remove the emulsifier or destroy the emulsifier in the given emulsion, the two components are separated out. There is de-emulsification. It can be done by heating emulsion to high temperature or by making use of suitable chemical reagents, etc., etc. Next bit, of course, the last one in this chapter is colloids around us and applications of colloids. See, we can find colloidal system in our food. Many of our foodstuffs are in colloidal state. Now, foods ella colloidal states alle irutte. Example, milk, curd, cheese, ice cream, cake, juice, etc., coffee, they are all in colloidal system. Generally, we used to take our food in the form of salts, colloidal systems, because in such state, our body can easily digest them. They are generally easily undergo assimilation. That's why our foods are in colloidal states. Next one, say in food. Next, medicines. Many of pharmaceutical preparations are in colloidal state, because in colloidal state they are highly effective. The high activity is mainly due to large surface area. When surface area is more, rate of absorption will be more. That is the reason. See, some tablets are coated with silver, gold, etc. Generally, they are used to increase the vitality of our body and to fight against some dangerous diseases like TB and other things. In medical field, you can find the application of colloidal systems. Next one, same, the toothpaste, shampoos, creams used in our daily life are in colloidal state. Cloud is a colloidal system. Cloud is a colloidal system. in which fine droplets of water are dispersed in air. Deltas. Deltas are formed due to the colloidal action, that is coagulation process. See, these are few examples of colloidal systems present around us. Now let us see the applications of colloidal systems. The first application is in making smoke precipitators. Cartridge smoke precipitators. So you know, in factories or industries, smoke is made to escape through the chimneys, that is smokestacks. See, like this. Okay, you know, smoke is a colloidal system. It is an aerosol in which fine particles of carbon are dispersed in air or distributed in air. It is a colloidal system. Smoke is an air pollutant. It causes air pollution. So in order to avoid that air pollution, in factories, the chimneys, an oppositely charged electric field is introduced. See, it is the stack or chimney where smoke is made to escape. So, at the top, when an electric field of opposite charge is introduced, the charge of colloidal particles present in the smoke lose their charges. That is, colloidal particles of salt present in smoke lose their charges. That means coagulation takes place, and those particles settle at the bottom, leaving behind pure air. That is, of course, hot air. By this way, you can avoid air pollution. And of course, it is based on coagulation principle. Okay. Next one, this colloidal chemistry is used in the purification of water. In the purification of water, often we use a substance known as alum. Alum is potassium sulfate, aluminum sulfate, 24H2. Potassium aluminum sulfate. It is used in the purification of water. Sometimes water contains negatively charged colloidal particles, particularly mud particles. Okay. Say, consider it is impure water containing negatively charged mud particles. When you add this alum into impure water, the negatively charged salt particles are neutralized by aluminum ions furnished by alum in the solution. So, coagulation of clay particles or mud particles takes place, and neutralized salt particles settle to the bottom. Okay. Whereas pure water stands at the top. Then it is carefully taken out, decanted. By this way, we can purify impure water, that is by using alum. Alum, once again, this process is based on coagulation process or method. Another one is, alum is also used as styptic agent. that is to stop bleeding. See, when cuts are appear on our body, if alum is placed on the cuts where bleeding is taking place, alum's aluminum ion coagulate blood, and or it helps to clot the blood in a short interval of time. As a result, the bleeding stops. This process is known as styptic action. Here, alum is used as styptic agent. In the previous case, alum, that is in the purification of water, alum is used as coagulant. That means the substance which is used to coagulate the given sol is known as coagulant. Next, it finds application even in artificial reining, etc. So these are few applications of colloidal systems. That's all about surface chemistry. So in surface chemistry, you can easily score marks, and you will get nearly 7 to 8 marks questions. That is, in the next class, shall see another unit.